Alright, moving on to question 13 in the 2019 B test. The question reads, a water hose is at ground level against the base of a large wall. By aiming the hose at some angle and squirting water at speed v, one wets the region on the wall as shown below. If the speed of the water is doubled, what is the new region that can be wetted? Ignore the effect of water splashing beyond the point of contact. Okay, this is actually a pretty interesting problem. So how I would approach it is I would first look at the fundamental kinematic equations that govern what's the exact, like how do we know exactly what range the water can go to and what height the water can go to, right? And how we can know that is by, let's first look at the range, okay? So when we're talking about the range, delta x, that's equal to the velocity in the x direction times time, right? So we're going to try to look at what's the effect of doubling the speed of water on this range right here, okay? So this question our strategy is to look at the maximum range in each of these answer choices and see what's the maximum range that doubling the velocity could give us. Well, first of all, what is this maximum range? Well, the maximum range will happen is, remember, we're spraying water at 45-degree angle, and we're spraying water directly parallel to this wall. So if this wall is right here, then we're just shooting water like this at 45-degree angle, and that will give us the maximum range. All right, so in this instance, by doing that, there's an equation, I don't remember the equation for the range, the maximum range of a projectile, so I'm just going to calculate it right now. So how I would do it is first look at the time it takes for something to be shot at 45 degrees to fall down. So if it's shot at velocity v, that means that velocity x and velocity y is equal to square root 2 over 2 times the initial velocity, right? Because it's at 45 degrees, and you use trigonometry. So the time it spins in the air is, if we look at the y, the change in y is equal to negative 1/2 gt squared plus vyt, right? But we know that the change in y, if we're talking about the entire time it takes for it to fall down, the change in y is going to be 0. That's equal to negative, so that's negative g over 2 t squared plus vyt. We already see that vy is square root 2 over 2v. But anyways, how we will, and then we solve for t, so that would give us g over 2 t is equal to vy, right? I'm just canceling out t on both sides, moving this over to this side. So t is equal to 2 vy over g, right? And then if we plug that back into here, let's see, that equals vx times v2, so 2vx vy over g. And then I want to plug in terms of v. Well, actually, let's plug 2 in terms of v because the question gives us that the speed v is doubled. So that's just square root 2 over 2 for both of them. So you get v squared times square root 2 over 2 squared, which is 1/2. So it's actually just v squared over g, right? So as you can see, the range, if we double v, right, and this is the equation for the range, if we double v right here, then that means that the range will also have to double, right? So that means that the width of this water beam also has to double, right? It reaches double the, sorry, not double, quadruple, right? Because if you double v, then that's v2 squared, and that's 4, so it needs to quadruple. So we can cancel out all the choices that don't have the range quadruples. So that leaves us with this one and this one, okay? So now the question is, does the vertical maximum height it reaches also double? And again, let's think about what condition will give it the maximum height. It gets the maximum height when the hose is pointing directly upwards, right? So that means that Vy is equal to V, and then Vx is equal to 0, right? And the range is delta y, okay, so that's the range, and that's equal to a negative 1/2 g t squared plus v t. Okay, it should be vyt, but since vy is v, let's plug that in immediately. And we want this equation, we don't want it in terms of time, we only want it in terms of v. So then now we need to find exactly what time so this time is the time it takes for it to reach exactly the top of the trajectory, the exact top of the trajectory. But by symmetry, recall, that means that the time it takes for it to go up and then go all the way back down, that's going to be 2 times this time, right? So if I say the time that for it to go all the way up and all the way back down, so that's going to be delta y is equal to 0. So that's negative 1/2 g, and then this is 2t, right? Because of symmetry, plus v times 2t again. So we're trying to find t in terms of v. So then we can move over to this side. So that gives us 2gt squared, right? Simplifying this down is equal to 2vt. Cancel this guy out, cancel this guy out. So that means that t is equal to v over g. So then if we plug it into this equation, then we get negative 1/2 g times t squared, which is v squared over g squared. Cancel this guy out. It doesn't matter anyways because it's a constant, and then plus, and then v squared over g. And as you can see, this also has, delta y also has a v squared dependence. The other stuff are constants. And that means that the range, the max vertical distance it reaches also has to quadruple, right? Because we plug in 2 times the velocity, then we have to get in 4 times the height. So the answer is D.